With HYDRO Basin, you can easily introduce more complex diversion operations using control rules. In this example, water is being diverted from the main river channel to a side branch. Such diversion is normally specified as either a fixed part or a fixed fraction of the main channel flow at the diversion point. In this example, there are two water users. The upstream one takes its water from a diversion branch. The downstream user has the highest priority and has a constant water demand of 5 cubic meters per second. It takes water from the main river, but also benefits from the return flow from the upstream user. The upstream user has the same demand as the downstream user and a return flow fraction of 0.5, which it returns to the main branch. With the river flow at the upstream diversion node varying between 5 and 11 cubic meters per second, it's clear that it will not always be possible to fully supply both users. We want to make a rule that diverts as much water as possible to the upstream user without jeopardizing the downstream supply. The control rule will be a function of 4 variables, which we call sensors, which are the river flow at the upstream diversion, the upstream demand, the upstream return flow fraction, and the water demand of the downstream water user. As background for the control rule implementation, the model was set up with the default diversion of 0 cubic meters per second. To implement the rule, first go to the sensor menu under the control section of the setup tree view. Click Tabular View to see how the 4 sensors have been defined. The first one, the upstream diversion point, is a model object of the river node type because it has to contain the net inflow to the diversion node number N8. The other 3 sensors are all external time series, selected as the time series defining the water demands and the return flow fractions of the respective water users. If you go to the Control Rules section under the General tab, you can see that we have defined a rule called downstream priority, referring to a river node, number N8, which is our diversion point. The controllable parameter, the parameter we want to manipulate with our control rule, is the upstream bifurcation time series for this node. Go to the Conditions and Actions tab to view the 3 conditions that have been defined to install the rule. In the first case, the upstream diversion point inflow is less than the downstream water demand. We want to maintain the default diversion, which is 0, since there is only enough water to supply the downstream priority user, so there is no action. The second condition is when upstream flow is less than the combined demand of the 2 users. Under this condition, the downstream user will be fully supplied if the diversion is set to the difference between the incoming upstream flow and the downstream demand, all diverted by 1 minus the return flow fraction. Finally, the third condition is when the river flow is larger than the sum of both water demands. In this case, there is an abundance of water and the diversion flow is simply set to the upstream demand. If, after having run the model, we look at the resulting flow in branch 2, we can see that we have generated a diversion flow that varies with time, sometimes fulfilling the demand, and sometimes creating deficits for the upstream water user. We can check this by looking at the relative deficit for the upstream user, showing deficits varying between 1 and 0. If we look at the deficit for the downstream priority user, you can see that the relative deficit is 0, meaning that the objective of keeping this user fully supplied has worked. And that's how you can introduce complex diversion operations using control rules in HYDRO Basin.